Good morning to one and all. I am Niharika Rawat, your host for today, and I take the opportunity to welcome you all to the second edition of Innovative Leader Talk series, organized by Naresh Vashisht Center for Tinkering and Innovation, NVCTI. The topic for today's webinar is Best Innovative Practices in the Context of Australian Mining. And we have Mr. Kumar Animesh, Manager, Integrated Planning at BHP in Brisbane, Australia. He has served BHP for over 13 years and has contributed significantly to the mining industry in the last 2 decades. He is an alumnus of IIT ISM Dhanbad from BTech Mining Engineering, batch of 2001. He has also worked with top notch industries in India before settling in Australia. On behalf of NVCTI, the ISM fraternity, and our audience, I welcome you, sir. Today,
Thank
we
you.
also have with us Professor Dheeraj Kumar, Dean International Relations and Alumni Affairs, Professor Pankaj Mishra, Associate Dean Innovation and Head of NVCTI, along with Professor Ajit Kumar, Events Coordinator, Faculty Innovation Cell NVCTI, to help and guide us throughout the event. Moving forward, I would like to invite Professor Dheeraj Kumar to welcome our guest and our audience. Over to you, Dheeraj, sir.
Thank you, Niharika. I, on behalf of the Institute and on behalf of the Department of Mining Engineering also, welcome Mr. Kumar Animesh, our own illustrious alumnus of 2001 batch in Department of Mining Engineering. And we have been quite fortunate here, Animesh ji. You have given us time from your busy schedule to address all of us, and you will be talking about innovative practices in mining industry, particularly in Australia, and will be quite benefited to after listening to your innovative talk. I welcome Professor R.M. Bhattacharya, the head of the department mining engineering. I also welcome our associate dean innovation, Professor Pankaj and Professor Ajit Kumar, and all of the viewers, all of listeners. And if you have any sort of queries, any sort of questions, I'm quite sure Animesh ji will be sufficient enough to address all your issues. Thank you very much, Animesh ji, for accepting our kind invitation to grace this occasion. Thank you very much.
Thank you, Niharika.
Thank you, sir.
Thank you, Professor Dheeraj. Good introduction. I don't think I need to really say anything else from an introduction point of view. But look, I'm really very delighted, glad to actually joining you all for this session. Obviously, it would be great to actually be there in sort of person in ISM, and probably having somewhere in either uh, Penman Auditorium or somewhere really. That would be the ideal. And then after that, maybe a cup of tea or something at Ramdhani. That would be the sort of ideal. My time in ISM would be. I Unfortunately, we are all living in this, I don't know what do you call it, extraordinary times really with this coronavirus, and everyone has their challenges. I guess you are all probably every day facing, how do we do the remote study, and how do we actually the study, how even even taking classes, exams. I guess it's all must be very difficult. Like I have my share of this thing as well here with my 6-year-old son. He had to do some remote learning as well, which was very, very difficult. I can tell you that. So again, we are all working in a different environment as well. Given we are remotely working, so I am sort of it's almost 6 months since we have actually gone back to our office. We just started only few weeks ago. So obviously the operations we are all like there are controls in place. So mines are operating with all our equipments and people there. However, in the corporate office where I work, we are mostly working from home, and only depending on the requirement, we are going to offices. So yeah, it's been a big challenge, and
Thank you, sir.
this topic is really good in terms of like that's innovation. But yeah, I guess anything else you want to add, Niharika, before we can get on to the topic?
Yes, sir. Before we move on to the expert talk, I would like to request Professor Pankaj Mishra, Head of NVCTI, to tell us more about Naresh Vash's Center for Tinkering and Innovation.
Thank you, Niharika. First of all, I would welcome Mr. Kumar Animesh, who is our 1997-2001 batch alumnus of the Department of Mining Engineering. So my responsibility is to introduce the center. The establishment of Naresh Vashi Center for Tinkering and Innovation is a landmark initiative and the result of the vision of our present administration. Okay, so the center has been established through the recommendations of 11th BOG of IIT ISM Dhanbad with the generous funding of about 810 lakhs from our distinguished alumnus of 1967 batch of petroleum engineering, Mr. Naresh Vasishji. The center is being set up in an area of approximately 11,000 square feet of the newly constructed CRE building inside the institute campus. Now, the broad objective of the center is to inculcate innovation culture among the students and to provide a state-of-art workspace to transform idea into product. Now, the center is going to have a full-fledged tinkering lab consisting of 5 different units, namely a mechanical and rapid prototyping unit, electronic, circuit and IoT unit, gaming and animation design unit, along with robotics and animation unit. There is another unit which is called pouch battery cell assembly unit. So all these 5 units will be full-fledged, self-sufficient, and fully accessible to approximately 1,500 to 2,000 students at a time, associated in different innovation projects. The activities of the center will be guided by an innovation council comprising student innovation cell, faculty innovation cell, and some invited members from industries and alumni. The proposed center will provide a platform for promoting experimentation, tinkering, and innovation activities among the students to enable them to contribute to the world of cutting-edge technologies and entrepreneurship. I'm sure once functional, the center will benefit not only to our students, but to the society at large. So with this, I again welcome Mr. Kumar and over to Niharika.
Thank you, sir. Thank you for sharing with us the progress and updates of the center. We now have a lot of people connected through Zoom and live on YouTube. I request all the audience members to drop their questions in the chat box on Zoom and YouTube, which will be taken at the end of the expert talk session. Also, for the best webinar experience, please mute your mics and turn off your videos. Without further ado, we now begin the expert talk. I would like to invite our speaker for today, Mr. Kumar Animesh, to address the audience and shed more light on our topic of discussion, best innovative practices in the context of Australian mining. Over to you, sir.
Thanks, Niharika. It's good to know, like, I guess what you described about this innovation center, that sounds really excellent. I think that's really the future, and I think it's great to sort of see that that's what we are getting ready for. So no, very, very good. Again, I'm extremely happy to be here and talking to you all. So let me just share my screen. Can you all see my screen? Okay.
Yes.
Yeah.
Yes.
You can see it.
Perfect. All right. So as I was saying before, innovation practices in mining, that's one of the topics close to my heart, actually. I've been working in Australia for the last 15 years, and I've seen the two different worlds in my 20 years journey. I guess for all of us in different aspects of life, things have changed. Things have drastically changed. Technology has changed the whole the way we interact. the way we work. But my journey, I guess I find myself fortunate to actually be working in Australia for the last many years. Given I actually had this opportunity to see these things, how the practices have changed, seeing the new technology, seeing actually best in the world technology, being part of it. And I hope that with my talk here, I can give you guys things that you can take away, areas that you want to skill yourself up, develop your skills in some areas, things that you want to actually research. You obviously Indian School of Mines is leader in the mining industry, not only in India. We are everywhere in the world. It's great to talk to all the future leaders. You guys are actually going to shape the future. So this is my input. This is future, and things as I said, it's changing fast. We all have to be ready, and it's good to see right at the very like just hearing about this Naresh Vashish Center. It's a great initiative. Okay, so probably start with just a bit of outline of what I'm going to talk today. Um, First one is safety share. Obviously, in the mining industry, once you start working in mining industry, the first thing which is important, the most important, I guess, is safety. So this is kind of everything we do. So anything we start, any initiative we have, safety is at the topmost priority. So safety share. I'll give you a bit of an insight into mining industry of Australia. I know, like most of you probably aware, but probably some of the students, who has not really who hasn't seen what mining industry, and who haven't really I guess read about or done anything research in terms of, okay, what is the mining industry outside India. I think that's just a high level introduction, what mining industry in Australia is. Then I would talk about planning improvements and innovation. I've worked in planning for a long time. I guess as my journey in Australia in BHP, starting from a mine planning operation role, at one of the mine site. Then I have worked in finance. Then I have worked in integrated remote center, and currently I'm looking after supply chain planning. So mostly planning. So that's close to me. So I will talk about some of the planning improvements and innovation. Then mine of the future. I guess future, we all want to know the future. Future is interesting, and in the mining industry is very, very interesting. So mine of the future, and then time for question and answer. So happy for you to ask many questions. I will try, make my attempt to answer you. Looks like there is something on the screen here. Can you see a arrow on the screen as well?
Yes, sir.
Yes, sir.
Is there a way to let me share my screen again? Better?
Yeah, okay, fine.
Cool. All right. So starting with safety share. As I was saying before, in mining industry, the utmost important thing is safety. If you talk about the three pillar, it's safety, productivity, and cost, but safety number one. So I just thought, given we are talking about innovation, we are talking about new technology, I'll give you, a share around tech, which is quite. It's not very new. Like it's been here for a little while. Probably in the coal mines, it's sort of started only a few years ago. But it's quite powerful. It's called driver safety system. So what it actually does, If on our mine site, one of the biggest challenges is fatigue. So to manage the fatigue, we have this is one of the system which help us immensely. You have a driver safety system which tracks drivers' heads and eyes. So it's a computer vision technology. It's in the cabin. It's in the cabin of the driver, and it's kind of monitor the driver facial movement. And there is a sensor which actually tracks if the driver has like a blink, if he has blinked his eyes, or if he's actually having some kind of a movement which gives you a feel of, okay, this driver is tired, or that there is this driver needs to stop. So what actually happens is this data is directly going to one central server somewhere, depending on which company provider it is. So it's like it's US or somewhere in Australia as well. So the data goes to that centralized center. At that centralized center, there are different machine algorithm built there that then kind of trigger alert, and then that alert actually goes to the mine control system where the controllers are there, and those controllers will then notify the supervisor of that area. So they'll actually just give a call, say, okay, driver XYZ on this truck actually it appears that there is some fatigue sign. So then, that supervisor straight away take the necessary action. So it's quite a powerful one. I'm not sure, whether this kind of tech is currently being used in India. But this is one of the safety. It's kind of reducing that fatigue related event to almost 70-80% because there is a watch all the time. So very powerful. I thought, starting with the safety and something that definitely, you can actually see how technology is making our minds safer. All right. Well, so to introduce you or give you a little bit of about Australian mining industry, one if I have to just describe it in one word, Australia is very big in mining. Mining is one of the biggest contributor in our economy here. It's a big employer. There are almost 1 million people in the mining industry, working in the mining industry. That's a fair bit. It's almost contribute 8% in the GDP. If you look at the map of Australia, so I've got a map here just to show you where and what type of deposits. So 19 useful minerals are there. This is one of the map from Mineral Australia, and if you I'll just see if I can get my mouse to sort of do the spotlight thing. Yeah, that's it. Can you see my mouse actually? If I'm hovering my mouse, you guys can see it?
Yes, it's visible. It's visible.
Yes.
All right. Okay, so that's the east coast of Australia. That's where I live, so Brisbane. And in the east coast of Australia, you have coal mines. So big coal deposits, big coal mines here. On the west coast, which is where the Perth is, that's where the big iron ore mines are. Gold mines are pretty much everywhere. Has the biggest resource in the world for gold. So, Sorry, just having a little bit of trouble with this share. Yeah, sorry. Let me know. Yep, I think you can see it now.
Yeah, it's visible.
Yeah, I don't know why I see an arrow here on the screen. Um, 1 second. Let me try again. Okay. So yeah, as I was saying, so in the west coast you have iron ore. In the north, got some big deposit, big mines of aluminium, so alumina. And in the south, you will have in the Adelaide. That's the area where we have uranium. So again, as I was saying before, Australia is big in mining. Some of the most competitive mine in the world. And if you talk about innovation, Australia is probably one of the world's most innovative. Australia has in most innovative resource sector. So in the mining, from the tech side of things, it's state of the art. It's best in the world. Just a bit about what are the key I guess features, or what are the sort of the core competency, what actually makes Australia such a successful in mining. Number one, high safety standard. As I was saying before, most of the companies in Australia, I think almost all, have a very high safety standard. They are very good in identifying hazard, assessing risk, implementing control, and then monitoring it. So safety is, again, it's a continuous improvement. There is a lot of focus across all the organization to make sure that the operating areas are safer. The statistics actually supports that. So if you look at the stats, if you go and look at Australian mining industry safety stats, you will find that the safety has improved significantly from where we were 10, 20 years ago to now. Again, it's still not 100%. So we're still on a journey. The end game is 100% safe, zero injury. So that's where we are aiming. So that's a high safety standard. Safer mines actually are the most cost effective and most productive mines. The next feature is large scale operations. So the mines here are big, as I was saying. Tonnage wise, almost mines are producing, almost 200, 300 million ton. Coal mines, a quite long deposit, 40 plus kilometer long deposit. I guess that's one of the picture here, just showing you, like it's almost an area of 15, 20 kilometers. Just the pits, the mine pits. On a 14-kilometer long strike length, quite productive. Big volumes getting moved, big equipments are there. So you can name any big equipment in the world, and they are their biggest trucks, largest shovel, drag lines. They're all operating here. The other important feature in the Australian mines are the remote asset management. I think Australia is probably one of the pioneer in managing the operation remotely. So most of the mine sites probably 1,000 kilometers away, and there is a centralized control center, where all the dispatch activities are happening. So mines are controlled remotely. Not only mines, actually, even throughout the supply chain, you have the supply chain. You have trains, ports. They're all sort of managed remotely. Driverless trains. Yeah. So you name. So Australia in the remote asset management is pioneer in the world. The last piece here is the planning and technology. So again, mines are very well planned and high tech. So that's the four, I guess, if I have to just summarize what makes it so successful. These are the four areas. Okay, moving on. So the first piece here, which I was saying around planning improvements, as I worked in mine planning for a long time, I would like to share with you some of the planning improvements and innovation that has been done over the years. Planning is the brain, planning is the backbone, whatever you want to call it. Everything starts with planning. That makes the mines safer, makes it more productive and competitive, cost competitive. Few things in mining, which I think interesting for definitely the mine planning. So the mining graduates would find this interesting. That's one of these are some of the things which are happening now. Some of you may be familiar with these tools that actually makes our mine quite efficient. 3D design. So back in India, when I sort of started working in mining industry, not aware at all at that time about the 3D, how you actually do the designs in three-dimensional. That not only helps understanding the plan, but that also makes the communication very effective. So when you are interacting with operators, you actually find it quite easy to communicate your message, because you can exactly show how the machines are moving, where the machine's going to be, and these 3D design tools are very important in the open cut setup. So open cut mine operations, this is quite an effective tool. The other thing in the planning I have seen over the years, when I started in 2007, we had mine design getting done in one tool, schedule was getting done in another tool. You had haulage planning getting done in again a different tool, and same thing with blending. So you had this different tools, and the problem we were having is it's not like it was not a very seamless integration. So it's, first of all, it was time consuming, and then the second thing was again it was prone to error. So you had something in your design that's not in the schedule, something in the schedule that's not gone into the haul, and then blend on all. Now what we see is we have one tool that actually does the whole design, schedule, haul, blend. That's making it very powerful. The mine planning is just by having that tool, integrated tool that actually make the plan more and more accurate. Scheduling production and supporting activities. So there was a time, when I started here back in 2007, we were only doing schedules for major equipments and big drag lines, shovels. That's the schedule you would do. But now in the capability of these tools are so big. Like you can schedule supporting activities like pumping. You can schedule activities like if there is a mud in the pit, you're scheduling mud removal, minor dozer work. So it's the production and supporting activities is again adding to the power of the mine planning. Single tool for all time horizons. So not only you can do planning for like a short term or a midterm, but you can do all time horizon planning from a day one to like end of the mine life in a single tool. That's the other big piece which has happened. That's one of the area which is making mine planning effective and quite powerful. As things are getting complex, as the mines getting deeper, these tools, accuracy of the estimate, accuracy of the plan is very critical, and these tools are making it happen. On the right hand side of the slide, I just have a just a small animation, just showing a drag line actually working in a pit, how it kind of digs the dirt, it's dumping the material. And, this is the thing which you give to the operators. So, they would actually see exactly where the machine's going to be, where it will sit. There are notes, you would actually put some notes as well on the plan that, okay, this is what you need to do for at that particular time. These are the activities that needs to be completed. And you can see, like, it started with all the dirt on the plan, and then I actually uncovered the coal. So that's the, I guess, some of the the powerful power of the tools. There are a lot of simulation works done in the mine planning, where you would simulate how the trucks are going from from the pit all the way to the final destination. Okay. Another thing in mine planning, I guess, mine planning discussion cannot be completed without talk about survey, because survey is what makes the planning more powerful. As you would know, when you do the plan and when you actually go and execute in the field, there is always going to be some deviation, some changes. You can never replicate 100% of the reality, and that's where the survey plays the big role. You and now with this UAVs, and where all the drones, you call it, you can actually make a plan almost in real time. So what you do is you do these flyovers, captures the data, and within 1 to 3 days you're actually updating the whole surface, or you are getting the latest and the greatest information. So with that information, then that goes into your mine design, and then from design it flows onto the schedule and onto the coal. So it's quite powerful. Back in the days, used to be almost 30 days or sometimes even longer. When you would actually go and do a flyover, used to be a expensive exercise as well. Now it's that's the power of tech, right? It makes things not only efficient, but at very, very cost competitive. So with the survey, all the big plans of machines, it's actually accurate. That actually helps in the plan compliance. So I guess in the bigger mines, when you are moving in order of 200 to 300 million ton of coal or dirt or any ore, plan compliance is very critical. So if you deviate from plan, either you are going to have delay in your accessibility to your ore or coal, or the other thing is it's going to cost you more. Just do non-complying to plan actually adds a lot of cost. So with these tools, or with this all this development in the survey, it's keeping on top of actual. So it's a great link between planning and execution. You actually have the machine guidance on the system as well, on the equipment as well. So those machine guidance are actually getting all this data, and then just making sure that the dig is complying to the design. So the compliance to the design is what is very important. One of the thing I got here is just around the high wall mapping. So these ones are almost 60-70 meter. The photo may not be giving you that sort of feel, but it's almost, when you stand in front of a 60-70 meter sort of wall, it's quite a view. These UAVs are actually helping. You do the high wall map. That's all the gaps which you have in your geology or in your geotechnical modeling. These UAVs are helping there as well. So that's thing. And I guess all these the mine planning and surveying which I talked about, they're all happening. They are kind of current way of work. This is the area where you have to skill yourself up. If these are not you see the power of these tools. You can implement, let's say, once you graduate from Indian School of Mines, you go out somewhere, if you're working in India or anywhere else in the world, you would find these tools. But if they are not there, you could implement, and that actually brings a big value to the organization, improvement in productivity, safety, and cost. All right. So that's the sort of current view. Now moving on to the next bit, which is mine of the future. That's the no, I wouldn't call it a dream now, because used to be a dream. And I remember even back in the days, and I'm talking 1997 to that 2001 period. We used to study about how the future of mining will be, and how machine and big machines, machineries, technology, but at that time we were not, I don't think we talked a lot about digital and virtual and that kind of thing. I think that those were not in not the part of the dictionary at that time. Now it's very common, and I guess just there as a data analytics, machine learning, or digital twin, autonomous. I think you must all have heard about it, in somewhere, in some ways. It's in most of the industry, I guess, are using these new tech and using the digital revolution. I think we call industry 4.0. I think that's the next industrial revolution. So and I guess the future of the mine is not, it's not going to be any different. It will be on these things. These are the tools of the future, and this is what will shape up the mine of the future. Some of the examples I've just got here, which things, currently, some of the mine operations, companies are working, they're developing using this data analytics and machine learning tools. One example here is about analyzing equipment delay data. So I guess, if you once you work on a mine site, I remember back in the days when I first started in Tata Steel, the first job as a graduate I had was doing a time study. Doing I think it was underground mines, where we just need to understand what time each activity takes, and where the delays are, and we would sit, like spend time in the underground, just noting the time, actually going night shift, and you're just constantly watching people, or the operation which are sort of happening. Those days are over. Those days are over, which is good. I think now machine does all the job. The data capture, this huge data capture. You actually capture every minute of data is stored in the system, and that data is getting analyzed. Once you analyze the data, and using some of the machine learning algorithm, this is an example of a Hollis system, where you actually looking at the delays, and then how you are actually going to feed that data back into your 24 hours plan. Because and again, 24 hours plans sort of sounds like, yeah, 24 hours plan, but it's not a very old sort of concept. It's fairly new. I remember when we started, we used to have like a weekly plan, and that kind of thing. And now it's getting down to 24 hours, even shiftly plan. You actually have that the details, and I guess the plan must be there, but the details in the plan, you would be amazed to see what level of detail it actually goes to each and every outage, every downtime, whether it's machine availability related or whether it's a utilization related. Every downtime is mentioned there, and getting a best estimate of those downtime is what makes your 24 hours plan more powerful. So that's just one example. The next one here is this is one in the sort of how you actually use the real-time plant feed data. So some of you may be familiar of on a mine site, you don't have and I'm giving you an example of a coal mine, so it's not one seam or just the one source. You will have multiple seams. They will have different quality. They will have different characteristic. They will have different wash characteristic. But when you mine, you're mining from different areas because you're trying to maintain the right sort of strip ratio. When you mine from different area and when you are feeding into the plant, to manage the ash on of the coal, which is also the directly related with your yield, it's quite difficult. And there is what's getting sort of done in the past. You would do the sampling every 2 hours, and in the dense media cyclone, so DMC here, so the dense media cyclone, you would actually go and reset the density of the cyclone. So it was more of a the ash, and then you after 2 hours, then you realize, okay, the ash is high, then you will set the density point. What this one does, it actually gives you in the live, sort of environment, that what the density should be. So SG here, the specific gravity. So what the density would be. So this is a system which actually taking the live feed data. It's actually giving you what's the density you need to maintain, and then what is the, I guess, the level of confidence. That's interesting as well, and that's what these tools, these systems do quite well. You can actually see the level of confidence is like 80%, 90%. And so what you would do is you would actually set up a bit of rules that if my prediction is say better than 80%, then I will actually go to and change the set point. So again, that's one of the things which is it's already happening at some places, but this is definitely where this will solve the problem of all the sort of complex deposit. The recovery is going to be not easy in the future. It's going to be more challenging to recover. The deposits of the easy deposits are gone. Now it's all the the challenging ones. So that's where the technology will help. Another one, which is the digital twin. I know that's a fairly common, I guess, terminology, or in the manufacturing setup. You probably have already heard about digital twin, which is more of a digital replica of physical assets. So instead of doing some changes or actually doing some experiment on going out in the real world, you're actually using this digital model, and then changing changing the parameters, testing the system. It's actually so cost effective because you can imagine if you are actually going and making a change in a drag line, and if it doesn't go as planned, the cost is huge. So this actually eliminates that thing from the equation completely. You actually with these digital twin, you optimize the operation and maintenance of how you operate, how you maintain. Right now there are sort of and these ones are happening at the moment, where you would even have virtual reality glasses. You will put on those glasses, you will go out in the machine, you will do the inspection. You actually have your handheld device, your tough pad, your mobile phone. You can actually mark different areas or within the sort of machine. If you see a crack, that actually makes not only your sort of current maintenance activity better, but it also for the future you are setting it up like you know exactly where the defects are. How do you actually have to fix it? You can actually in the real time you would see the last inspection report. You could actually just go to that area, you click, you can expand, zoom, and you can see, okay, what was the work done last time, what's happening, sort of what needs to be done now. So again, this is just an example of dragline digital twin. There are, it's you can use it for the processes as well. The supply chain is again the area where I'm working, and I have seen different form or different types of digital twin. In the sort of not for the whole, I guess, chain, but you for some component or some areas, you actually have a like a pretty much a replica of your rail and your port systems. So that's definitely one of the area from a equipment maintenance point of view. I think it's going to be big. It's already, like in Australia, it's already started changing the way the equipments are maintained. All right, so I guess. So what's sort of like the end state, or like the ultimately the future, and I guess it's nothing different to what you have seen in the other industry or other parts, I guess, other aspect of the life. It's basically automation. So automation across the value chain is the future of mining. Automation, whether it's starting from the exploration, so in the geology space, real-time exploration planning, uh, live geological modeling. Sorry, I'm getting some feedback.
Yeah, you can take at the end of the session. You can take the questions at the end of the session. You can continue now.
No, I'm just getting some feedback. Like I'm just hearing my own voice for some reason. So that's the feedback I was saying. Like I'm just
Okay.
yeah. If looks like somebody on.
If anybody has on his YouTube or Zoom simultaneously, please switch off one mode. It's a humble request. Please switch off one mode.
So one of the participants has his mic on.
I
Now
am
it is
muted.
off
I am
now.
muted him.
Okay.
Yeah.
So I was saying, like the automation from for the first activity. So value chain, I guess, this is what we call the entire sort of mining activity. So starting from exploration all the way to loading the ore to at the port. Most of the, I guess, Australian mining, the product is export. So that's where the value chain concept is all the way from the mines to the port. There are things that are coming up, real-time exploration planning that will make the whole exploration planning cost-effective. Live geological modeling. So these are not very far. Like I think it's probably I was reading other day from one of the I guess big research sort of company within Australia. They probably think it's another 10 years. 10-15 years. So I guess this is pretty much the area where most of the the students like in the next few years they'll be actually working in some of these areas. So quite interesting, challenging as well, but quite interesting. So we're going back, drill automation. Drilling is one of the activity, key activity in the open cut and around as well, automation of live blast design optimization. So again, these are all adding to the productivity and cost. So that's the theme. As the mine gets challenging in the future, with the complex deposit, with the cost pressure you will have, the volatility in the market. These things are actually will make companies stay on top of everything. Drill automation, blast designs, that's coming up. Automated digger, excavator, and dozers. I think there are few places here in Australia they have already started trialing. So that's definitely the sort of the future. Autonomous haulage. I think Australia is probably one of the early, I guess, pioneer actually in this area. Early adopter of this technology. Already in the iron ore, there are mines which have autonomous haulage, so which is driverless trucks. You have this massive big trucks, 400 tonners truck. They have the system installed, high precision GPS. They have a plan there, and they're pretty much manless, and then the best piece is like that's all being operated from 1,000 kilometers away. That's the incredible. So autonomous haulage, that will go big. I think we all I think have been waiting for autonomous cars on the road. That may probably take longer, but the autonomous haulage is just happening. It's already happening, and more mines will go that path. It makes the what it does, it improves the safety quite dramatically. It actually improves by 70-80%. Makes mines more safer. So you are actually removing people from the hazard, which is I guess that's the ultimate sort of aim. So autonomous haulage, processing plant. So again, more automation in the processing plant. Automated plant feed. On the rail side, rail automation, I was saying before, Australia already have companies who are running driverless trains. So fully automated. You don't need any operator, running for like 1,000 kilometers plus. So that's the rail automation. Then again at the port, you have the port docking and the automation of that port, loading activities as well. So when you see from this from end to end, that full automation is where the future of the mining is. That's where it's going. I guess different speed at different part of the world. But one day, or everyone will be there from a mining perspective, for the mines. So yeah, I guess that's pretty much I have. I hope you have you've got few things to think about, things where you can actually look into develop more skills. Maybe do some research. I guess that's the future. That's where we got to be. All right. I think that's it from me. I think I've done all the talking. Thank you. Happy to take some questions.
Niharika, you can please take the
Yes, sir.
questions.
Yes, sir. Thank you, Animesh, sir, for this amazing session. It was great to know about the safety procedures, the mine planning, and the future of the mines. And as you told, Australia is the best in managing remotely. And it is always good to learn from the best in the industry. So thank you for this wonderful session, sir. Now moving on to the question and answers. We have our first question from Head of Department of Mining Engineering. He says, can you please explain the sizes of the benches in coal or OB vis-a-vis the sizes of the machine to show the high capacity of bulk production?
So the bench sizes, I guess, in the coal mines, you would have 30 meter, 60, 70 meter wide benches. Sometimes you do 120 meters as well. You would have equipments that, and again, the width of the machineries are width of the bench is designed based on what your big equipment width are, and again taking safety into consideration. So like if you actually have to operate 300 or 400 tonner trucks, then you would need for actually running a double circuit, you would need almost like 120 meter wide bench to operate those trucks. Similarly, again, with the depending on what method of mining you are using. So for a drag line, it's 60 meter high benches as well. So you would actually need drills that can drill that much. So big drills, and with the size of the drag lines, obviously drag line would require most of the mines where sort of my experience been is they normally do like a 60 meter wide benches, depending on like the drag line configuration. That's the 60 meter wide gives you the best I guess productive output.
Thank you, sir. We had one more question from HOD, sir, about the application of virtual reality in mine planning, operation, and safety. What is your take on it?
So virtual reality, as I was saying before, the virtual reality is, like if you think about safety, I think in the training area. So instead of a driver getting trained in the field, is actually getting trained in a sort of simulation. So there are simulators where operators will go and train themselves. Working for if there is a shovel operator or there's a truck operator, you can actually just use that virtual reality, and he would actually get himself trained or herself trained in that environment, in virtual environment, rather than actually exposing themselves in the field as a sort of as a learner. So there is this huge you would like as I was saying before on the maintenance, the just around this ability to actually see the machine like in a virtual sort of world. You actually get much more insight. You actually even not exposing people to sort of those high risk areas. So there is a tremendous, I guess, opportunity in the sort of virtual I guess implementation of or use of this virtual tech. Mine planning, obviously, in a simulation, is the world where you actually you do blast simulation, you do with the drag lines, all the machines, you actually see you can see the result beforehand. And you can actually fine tune your plan. So from a planning and safety point of view, tremendous potential for virtual reality.
So we also had questions about what are the softwares being used in coal mining, and is BHP using robotic process automation?
Look, I can tell you about some of the softwares which which are used here on the mine site. I think Maptake, Rangi, there's some of the Desvik, they are some of the big mine planning software companies. I think Rangi probably have even offices in India as well. These are the big mine planning company. With regard to the robotic process automation, I guess this must be happening. I wouldn't like to comment on the sort of BHP specific, but I think those ones are happening in different parts of the business.
Thank you, sir. We had one question saying nowadays people often say that the era of mining is gone now. Future of the world is renewable resources. What is your take on it?
Yeah, I think people don't realize that how much mining is in their day-to-day world. You pick up a phone, wouldn't be there if there is no mining. You drive a car, wouldn't be there if there is no mining. So I guess there is one view of the world around some of the energy sources. I guess definitely, I understand that, but mining is in every aspect of our life. You can't really separate mining. I think there was somewhere I read, what's not what you can't grow, you have to mine it. So for the future of humanity, like all these tech, the copper, the electricity, it's not all just coming from somewhere. It's all mining. So I think the future of mining is bright, and in fact, better than any time in the past. I think it definitely needs that the technology is actually making it much more superior. So I think yeah, I would say a mining future is secured.
Another question that we have is that the future of mining is data analytics and machine learning. So, what are the key research areas which will be growing in data analytics and machine learning in the mining field? And also, if the process is automated, if we get autonomous technology in mining, then it will result in downsizing of the mining industry. A lot of people will lose jobs. So where will the job opportunities be created, if at all they are created? These are the two questions.
Yeah, look, I think there is a common perception about, tech actually takes the job. However, all it's doing is it's giving you a different challenge or different problem to solve. So you see tech as an opportunity. It's not as a threat. There are obviously you have to skill yourself up. So to actually, so the future in the mining industry, there will be more, the workforce will be more tech oriented, and I guess the industry, or even there is a big focus on that. So obviously at the end of the day, the people still the center of the whole thing. It's all centered with, like, people are driving everything, whether it's autonomous or something. It's all somebody is controlling. As I was saying, even at the remote control center, you have somebody sitting there and actually making sure that all the systems are working perfectly, or working correctly. So the few, like, I guess what I wanted to highlight is, as a tech graduate, one, I think these skills in data analytics or machine learning, these will be the basic skills. Like, these will be the engineer's toolkit. You need to have these things. You need to know these things. You may not be, like, you may not be programming something, or you may not, you may not be actually writing the codes, but you need to understand. I think you need to understand your area, like from a subject matter expertise point of view. You need to understand the mining and mining process as well, and then you need to also know the capability of all these technology and the tools. And this is what you will be doing in the future. You will be actually utilizing your subject matter expertise, and you will be actually using these tools to make, I guess, more productive, safe, and the cost competitive mining.
So, what is the participation of women in Australian mining industry?
That's a very good question. In Australia, there is a big focus on women in mining, and every company actually has has got very ambitious target around getting women. I think diversity is very big on our agenda. Women participation, I think the aim is to have 50-50, if not more. And there are many companies who are actually very getting close to that, and I'm proud to say that BHP is one of them.
Okay, sir. Is mining responsible for changing the structure of the landscape? If yes, then what is the impact of climate change in respect to the local community? And what current innovations are going on in Australia on underground stability analysis?
Yeah, look, the mines, the big mines, obviously, they have a big footprint, and obviously the mining, changes the sort of landscape when it's sort of in operation. However, there is a big focus in terms of making sure that the rehabilitation. So when you finish your mining or when you complete that operation, you're actually restoring the area back to where it was, or back to the sort of best possible I guess environmental friendly state. So there is so in that side, I think again, Australia is probably one of the pioneer, like in terms of making sure that once you mine, the land is sort of get back to the area is get back to that same state. Underground mines, there is a big, I guess, like in terms of the analysis of the data around what will happen to the surface and subsidence and all that. That's studied in quite a big detail. And there are always plans in place to make sure that it has minimum impact to the sort of user of the land after the mining is complete.
Okay, so Professor Bhattacharjee is asking about opportunities for our graduates to be employed in Australian mining industry, and if there is any orientation required for the students.
Yeah, look, there is, opportunity. I think big opportunity in mining industry. I guess the skill set. Obviously, what I was I guess one of the purpose of my talk to touch on these areas was this is the area where you need to develop your skills. So having I guess good understanding of the new tech, having a very good understanding of planning itself. I think planning, most of the mining graduates or mining professionals will work in the planning area. So knowing the some of the tools which I talked about, some of the I guess the text, data analytics, machine learning and all that will help. We have in the past, I guess I was probably fortunate to have interviewed some of our Indian School of Mines graduate back in 2008-9. Yeah, look, there is always opportunity. I think I'm not sort of I guess very sort of familiar in terms of what's the sort of easy path towards here, how you get here. But companies, I think some of the companies actually have big offices back in India as well. They actually have a big setup in India, and then that's where as the things are done remotely. Planning can be done remotely, so there are definitely opportunities.
Thank you, sir. So we have our last question here. A student is asking about how can we get the industrial data related to drill blast or other parts of optimizing using machine learning.
How can we get the data? Yeah.
Yes, sir. Industrial data.
Yeah. So look, and this is and as I haven't worked in sort of Indian mines for longer period, and I don't know how sort of data gets captured, but here, like on like most of the mine side, they will actually capture. So there's there are systems, inventory accounting systems. There are data capture system, which will capture the data for every activity. That data sort of gets stored, I guess, somewhere in the cloud probably nowadays. That data is then, like you would have access to the data, and you query those data, to actually, whatever. I guess whether you're building a model for a machine learning, or whether you are doing some kind of a supervised learning, or so there is a big set of data. Like every mining company, they're capturing all the data. The data is, so that's the other big thing with like with having those GPS and those ones on every equipment. We are actually capturing every movement of the machine, and you're capturing the data around your production. So if the question is about where to find it, I don't know whether there is these data is accessible sort of to everyone. But once you are part of the company, once you are part, once you are working, yeah, you'll get huge amount of data to actually work with.
Thank you, sir. With this, we have come to the end of Innovative Leader Talk Series 2.0. I am sure we are taking back a lot of learnings from today's webinar. I would like to thank Kumar Animesh, sir, for this fruitful session. It was an absolute pleasure listening to you, sir. I would also like to thank Professor Dheeraj Kumar, Professor Pankaj Mishra, and Professor Ajit Kumar for making this webinar a wonderful one. I would also like to extend my heartfelt thanks to the whole Faculty Innovation Cell and the Student Innovation Cell core team for working tirelessly for today's event. Above all, I would like to thank our dear audience for being great listeners, posing incredible questions, and making this webinar a two-way session. Thank you everyone for being here. Stay safe and healthy.
Thank you all.
Thank you.